What's up, everyone? Welcome back. Patrick here. Moving on to the next question, still dealing with circles. So there's a lot written out in this question. If you don't want to write all this out, you could just print out the lecture notes there at the beginning of the section. And if you're watching this on YouTube, you can go to the course website that's found in the description box. There's a link there where you can find those lecture notes. So in this particular question, we're given a circle, x squared plus y squared is equal to 26, and using that circle, we have to answer these questions here. So we have to verify -5 and 1 lies on that circle, and then in part B, we have to find the equation of the line from that point, -5 and 1, to the center of the circle, and then in part C, we have to find the equation of the tangent line. I'm going to explain in a sec what this means, this tangent line, that's perpendicular to the line in part B and passing through -5 and 1. So before actually getting into the details of this, I'm going to draw a diagram of what is happening. So we have this circle, x squared plus y squared is equal to 26. Now, whenever you have a circle in this format, right, x squared plus y squared equals r squared, especially when the left side is just x squared plus y squared, there's nothing else going on the left side. It means that a circle in this format, its center is always going to be at 0 and 0. We're going to go through videos where we're going to be dealing with circles that have a center other than 0 and 0, just in case your teacher is dealing with those kinds of circles. But anything in this format, any circle in this format, it always has the center at 0 and 0. So the center is going to be over here. And so if we draw this circle, it's going to look like that, let's say. So we have this circle. Now, first thing we got to do in part A is we have to verify -5 and 1 lies on the circle. And so -5, 1, let's say that that's going to be like over here. Okay, so that's going to be the first step. We have to verify that that point lies on the circle. And then what's going to happen is in part B, we have to find the equation of the line from that point, -5 and 1, to the center of the circle. And the center of the circle, as I mentioned, it's this point. It's the 0 and 0. So we're going to have to find the equation of this line right here for part B. And then in part C, we have to find the equation of the tangent line. And just for now, you could even forget about this word. Let's just keep it more general. We have to find the equation of the line that's perpendicular to this line that we found in part B and passing through -5 and 1. So it's going to pass through this point and it's going to be perpendicular to this line. So that line, it's going to look something like that. Right? Passing through this point, -5 and 1, and it's perpendicular to this line over here. Okay, now why it's called a tangent is you could just Google image this and you'll see that it's basically lines that are going through the graph of a function or a relation that are just touching the graph at one point. Okay, and it doesn't have to be necessarily for a circle. This concept, by the way, a tangent line, you're going to see come up more in grade 12. It's a very important concept in calculus. So you're going to be dealing with tangents more in higher grades, but tangents can be on anything. So they could even be on like a quadratic, a parabola. So let's say over here at this point, a tangent line would just touch that point like that. Okay, versus a line that would go through 2 points. Okay, this line is called a secant. Right, a tangent line is only a line that's going through 1 point. And so notice how on this circle, it's not going through 2 points, it's not going through the circle, right, directly with 2 points. There would be 2 points of intersection then. There's only 1 point of intersection with this line over here. And this line can be anywhere. It could be here, right? If you had a tangent line at this point, it could be here, etc., etc. So that's basically what a tangent line is. So let's go through these steps. I'm going to actually erase this here, give myself some room. So first we have to verify that this point, negative 5 and 1, lies on that circle, x squared plus y squared equals 26. How do we do that? Well, as we've done in previous videos, what you do is you plug in the point for x and y, and then you just make sure left side is equal to right side. If it does, we confirm that it's on the circle. So if we plug in negative 5 for x, if we plug in 1 for y, we'd end up with 25 plus 1, which would give us 26. So 26 is equal to 26. All right, so that's part A. We verified left side is equal to right side, so this point we verified lies on that circle. Now what we have to do in part B is find the equation of this line over here. And so notice that we have 2 points for this line. We have the point negative 5 and 1, and then we have the point 0 and 0, the center of the circle. Okay, so let me write out these points over here. And let's label these. So this will be x1, y1, this will be x2, y2. So the first thing we could do is find the slope of the line with this formula. So we'll have y2, 1 minus y1, which is 0, x2, negative 5 minus x1, which is 0. This would be 1, this would be negative 5, so negative 1 over 5 ends up being the slope of this line. And notice it makes sense. We have a negative slope. We have a negative line right there. Okay, so now once we have the slope, we could plug in the slope and then solve for that b value, right? Another way to solve for the b value is using that formula, right? You may be using that formula in class where you plug in the slope, then you plug in for x1 and y1. Actually, you could plug in either of these points, and then you'd bring everything to one side except for this y, and then you'd end up with your b value. Personally, I just like to use this over here. And between these 2 points, it doesn't matter if you plug in this one for x and y or this one for x and y, you're going to get the same b value. In my opinion, obviously the 0 and 0 is easiest to plug in because you'd end up with 0 equals 0 plus b, and then the b value is just 0. And that makes sense from our diagram, because remember, what is the b value? It's the y-intercept of the line. If you look at the diagram, the y-intercept, if you kind of ignore the circle and just look at this line, the y-intercept of this line is 0. It's going through the origin. So the final equation of the line in part B is going to be y equals negative 1 over 5x plus 0, but the plus 0 we don't have to write. Right, so that's the answer right there to part B. Now with part C, what we're going to have to do is find now the equation of this line, of this tangent line. So notice that this line, this tangent line, is perpendicular to the line we found in part B. So what does that mean? It means that the slope of the tangent line is going to be the negative reciprocal of the slope from the line in part B. And so if the line in part B had a slope of negative 1 over 5, well, the perpendicular slope, we're going to flip this, so it's going to be 5 over 1, and then change the sign. Negative, this is going to end up being a positive, right, which would just give us positive 5. Okay, so the perpendicular slope is 5. The slope of this line is positive 5. That makes sense. Notice how it's a positive slope right there on the diagram. And then we have to solve for the b value. So we'd plug in the slope. So we got y equals 5x plus b. Again, you could plug it in here if you want. If you're using this in class or if your teacher requires you to use that, you should get the same b value that I'm about to get. And then from here, with this particular line, we have to plug in negative 5 and 1. So you got to be careful because this line is not going through 0 and 0. So we can't plug in that point. We have to plug in this point, negative 5 and 1. So we'd plug in 1 for y, and then we'd plug in negative 5 for x. So we'd have 1 equals negative 25 plus b. Bring the negative 25 over. 1 plus 25 would give us 26. Okay, so the tangent line, the answer to part C, the tangent line has an equation y equals 5x plus 26. All right, so first we had to verify that that point lies on the circle, then find the equation from that point to the center, and then we found the equation of the tangent line, which is perpendicular to this line, and passing through that same